doesn't have it on.
Oh, he just texted me.
Okay, so to get warmed up.
Dog over? No. Dog over. Then you put it on the grill.
All right, what's the first thing I should do for this factoring problem? Very good, GCF, you guys are so smart. What is the GCF?
Why?
2Y, very good.
Why?
Good start to the second semester. What goes in the parentheses, Grace?
Y2 plus 2y minus 50.
Very good. Can we factor that trinomial?
No.
Yeah.
No. No.
Yeah, you can.
Oh, dang it.
How do I factor that trinomial?
Are you screen recording?
Yeah, thanks for checking though.
You're welcome, man.
Oh, would it be cuber because you can't do, I mean, not cuber, but square root?
Well,
So y,
it's just a regular trinomial.
y plus 2y, y minus
No. Come on. What times what is that? Added is that?
3 times 5
Good. Which one's the which?
minus 3.
Okay? This is a normal regular trinomial, right? Factors of C that add up to B. All right? We okay so far? That's nothing new, is it? Stuff we've already done, right? How about number 2 there?
Three.
Yeah. 3 is a GCF, right?
Oh, 3.
Wait, we're after the 3.
Just 3, because
Just 3.
no X was a 24.
Just 3.
So, Joey, what's left?
X to the fourth. Minus 2x to the second. What, minus 8?
Good. Can I factor that trinomial? Are there factors of 8, or I'm sorry, negative 8, that add up to negative 2? Negative 4 and a positive 2, right? What goes in front of the negative 4 and the positive 2? X squared, yeah. Because it was x to the fourth, so we split it in half, right, when we do that? Into x squared and x squared. Is that finished?
No.
No. What else can I factor? Okay?
The first one's different than squared.
That's the difference of squares. So how do we do that?
X minus 2 and X plus 2.
Right. So that's factored completely now. Okay? Questions so far? Again, none of that's new to us, right? We have done that already. More than once. Okay, so what's the difference between those two problems and 3 and 4?
They equal 0.
Right, so what does that mean? So all we did was factor 1 and 2. For 3 and 4, since they equal 0, I have to figure out what?
What is 0? What equals 0?
What value of x will make it 0, right? I have to solve it, that's, all right, so,
Did you just put it at 0? Doesn't everything times zero equal zero?
Yeah, but then 0 minus 9 is not 0.
I right.
So go ahead and factor that.
Plus 9.
No.
Oh.
I heard somebody. Thank you.
Oh, I get it.
Right, square root, right? When it's a difference of squares, we take the square root of both of them, right? One's plus, one's minus. So then our zero product property says, if this times this is 0, either this one equals 0 or this one equals 0, right? So what do I do to get x alone here? Subtract 3, right? So this 0 or root is negative 3. Here I have to add 3, right? So we call those zeros or roots. Right? Another way we did this was we added 9 and took the square root of both sides, isn't it? What symbol did we have to use when we took the square root of both sides? Plus or minus. So there's your plus 3 and there's your minus 3, right? So that was another way we could have done that problem. Right now we're kind of thinking about or concentrating on factoring. Okay, what about this one over here? There we go, let's do this. What can I pull out of there? That's got a GCF, that's an X, right? And I get x squared plus 3x minus 4. Are there factors of negative 4 that add up to positive 3? Right, 4 times negative 1 is negative 4, and 4 plus negative 1 is positive 3. So what are my 3 zeros? What's this one? Wrong. Negative 4. This one? 1. What's this one?
1.
0. Okay. So that's solving by factoring. We did a lot of that in chapter 5 with quadratics. This one is a cubic, degree of 3, which means there's 3 zeros, right? Quadratic, 2 zeros, right? Okay? So, here's what we're doing. We're finding real zeros of polynomial equations, all right? We're going to talk about something called multiplicity of roots. Roots and zeros are the same thing, okay? Use the rational root theorem and irrational root theorem to solve polynomial equations. We're not actually going to do that because we have a calculator that'll find our roots for us. We're not going to have to use those 2 theorems, okay? There's a way to think about the possible roots of a polynomial by looking at the first, the leading coefficient, and the constant, the first term and the last term. And using some division, you can figure out possible roots, and then you have to use synthetic division to figure all this out. Okay, we're not going to do all of that. Thanks. We're not going to do all that because our calculator is going to find those for us. So I'm just skipping over that. Okay. So back the last lesson, we used several methods for factoring polynomials. You know, we had grouping and we did cubic stuff, right? the sum or difference of cubes. As with some quadratic equations, you know, the x squared ones, factoring a polynomial equation is one way to find its real roots. The zero property from section 5.3, you can find the roots or solutions of the polynomial equation by setting each factor equal to 0 and solving for x. That was what we did with that number 3 and 4 in warm-up, right? Once we had them factored, we set them equal to 0 and then solve for x, right? So we're doing that same thing, okay? So factor this. What should we look for?
QCF.
Good. What is it?
4x to the 4th.
Good. Then we have that, right? So what's that trinomial factor to?
X4, wait, X4, that.
Wait, what do you do after that?
Come on, there's factors of -6 that add up to +1
-2,
and
1, 3.
+3, yeah.
I was idiot.
Okay? So what do I do with each factor now?
Find what equals x.
What makes it equal to
0.
0, right? So when I have x minus 2 equals 0, what's the root or the 0? +2. When x plus 3 equals 0, what's the root or 0? -3. What about this one? Yeah, it's just 0. Okay? I'll just get rid of that. All right, let's give ourselves, let's give myself some room here. All right, what am I going to do with that 4 if I'm solving that one? Dividing by 4, right? What's 0 divided by anything? 0. How do I, if this was x squared, what would I do to both sides? Square root of it. Since it's x to the 4th, what do I do to both sides? Quad it? Yeah. Quad root? Yeah, 4th root. Okay? If you have to do that, again, you all know this answer is what? 0. But if you need to find the 4th root of something, all right, put the number 4 in, and then this symbol is in the math screen, all right? So you hit 4, and then math is right here under alpha, and number 5 is for any root that you need to do, right? So cube root, it already had a cube root button, right? Square root's got a square root button. 4th, 5th, and higher root, you put that number in, whatever it is, and then that's this button, and then the number, okay? Now, we all know the answer is 0, but like 16 has a 4th root, all right? So you could do that, hit enter, and it would tell you that the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. Ava. It's not really multiples of 4. We're just, what times itself 4 times equals that is what we're thinking. Okay? So if you run into a problem where you have to find a higher root than cube root, okay, your calculator can do that for you. Again, whatever root you're trying to find, so this was 4th root, we hit 4, and then math, it's number 5. Okay? So what you're telling the calculator is you're putting a 4 in for that x. So it looks like this. That's called the index. Okay? We don't put a 2 there when it's square root. If there's no number there, we know that it's square root. So once we put a number there, like a 3 or 4 or 5, it's 3rd or cube root, 4th root, 5th root, whatever. Okay? Just something to help you out. Okay? So, this is the graph of that problem. Okay? What number's right there? -3, right? What number's here? That's the 2, right? What number's right there? That's your 0. What did the graph do at 0? It went up, and then what? Went back down. I call that bouncing off the x-axis. When it goes up, it hits it, but it does not cross it. It actually switches direction. I call that bouncing off. Okay? We're going to talk about that in a few minutes. Okay, so if you have trouble factoring something like that, where could you find these 3 answers?
In your calculator.
Right. Where do you look?
On the graph.
Where it crosses the x-axis. You understand that? So if you're getting stuck, because some of these are pretty tough to factor, just put it in there y equals, graph it, okay? And see what those numbers are. Where could I make sure that those are the numbers that work? Table, right? All right, we'll do one, and we'll go through it, all right? So let's look at this one. Instead of factoring it, which we can do, we'll just put it in the calculator. Before I put that in the calculator, though, I have to set it equal to what? 0. So what do I do to get it equal to 0? Right. Subtract the 26x squared. Where's that going to go? In the middle, right? You guys all understand it should be in this order, correct?
You don't have to add like a 3 and a 1, right? Like an x cubed and an x cubed.
If we were doing some synthetic division, which we will be doing, yes. Or if we were doing long division, yes. But you don't have to when you write it in your calculator or write it out. Okay? So you go to your y equals and put it in. So here's your x. You guys should be getting familiar where to find it. Okay? Use caret for exponents 4. And then minus 26x. Now you can use caret 2, or there is a square button right here on the left side there. Plus 25. Hit enter, and then hit graph. Down, up, down, up. All right? How many times does it cross the x-axis?
4.
4. How many do we expect to find?
4.
4. Joseph.
How do you keep it on the calculator?
Hey, Dave. What's up, buddy?
Tomorrow's Gary's birthday, apparently.
Yeah.
It's on the birthday.
Okay? So, what are these 4 numbers?
Looking like negative.
Where could I check to see what they are?
Table.
Table.
Negative.
So, here's what? -1, and those are these 2, right? So I need to go further left. -5, what's the other one?
1.
+5. Just check to make sure, but in your table, you can see 4 zeros, right, Gabe?
Yeah. Right.
Thank you. Okay? So from your table to make sure, it's pretty easy to see that this is -5, that's -1, that's +1, and that's +5. Okay, if I were to factor this, it would be x squared minus 25 and x squared minus 1, and then x plus 1 and x minus 1, and x plus 5 and x minus 5. There's your -5, there's your +5, there's your -1, there's your positive. Okay, so it's not that bad to factor. But this, a little bit quicker. Those are our roots, our zeros. It's okay with me if you use your calculator to find these. Okay? Right, Abigail? Okay? Do that one using your calculator. Do that at home. Now you got, now you do know.
Oh, I did do it right.
Now, you know what you're doing. Oh, I know, it's why we.
Mr. Matthews, figure out what we're doing.
Yeah, 2E.
Yeah, I didn't make a table.
2Y. Or 2 is academic graph. Alright, go back. Keep going left. Okay, now keep going. Alright, now go up. Keep going up. See the plus there. Okay, good. Now hit enter. Now go right. Pull it down. Keep going. No, that's good. Now go down. Now hit enter.
I only 3 inches.
Yeah, probably 0 that one. Go to your table, see if 0 is 1. Second ground. Which is actually the back ground. Whoa. So 3 are down. I know, but why are you starting at negative 130? That is 1. There's another one. Here's go up. Must put 4 times. There we go. Yeah, way over there. So that one must work 4 times. It's got multiplicity.
Let's see it, Hannah.
Good job.
All right. So, what were your zeros?
Six,
You should have got those, right? Now, how many should we have of them?
6,
6. We only see how many?
3.
3. Okay. Now, let me show you. I'm gonna factor this, and I'll find those same 3. Okay? But I wanted you to practice on your calculator. All right. So 2x to the 4th is my GCF, right? And then I got x squared minus 5x minus 6, right? And then I still have that 2x to the 4th and an x minus 6 and an x plus 1. Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5, right? So this is a negative 1, that's a positive 6, and then this is a 0, right? These two work once. This one works 4 times. It has an even multiplicity. Okay? Multiplicity means the 0 works more than once. Okay? When it's even, the graph will bounce at that 0. Isn't that what happened? Didn't it go up and hit the 0 and then change direction? okay? That's all, whenever you see it bouncing like that, it has even multiplicity, meaning it works at least twice. Okay? But this one actually works 4 times. When it goes straight through, like you saw on your graph, it works just 1 time. Okay? So, then 3 things can happen when you look at the graph. The line will go straight through. The line will bounce off. Or the line will bend as it crosses. So it's coming up like this, and then it kind of bends as it crosses. Looks like that. Or it's coming down, and it'll look like that. Okay? If that happens, it has odd multiplicity. It will work at least 3 times as a 0. Okay? If it bounces, it works at least 2 times. If it goes straight through, it works once. If it bends, it works at least 3 times. Okay? So, let's move on to this problem. Right, so that's what I just talked about, multiplicity. Even multiplicity, the graph touches but does not cross. That's what I call bouncing. It hits it but doesn't cross it. So I just say it bounces up. When it's odd, it'll bend as it crosses. Okay? So, this graph here is the graph of this polynomial there, the 3 plus 18 plus 27. Okay, so that's this picture. Okay, at -3, it bounced off. It has a multiplicity of 2, even multiplicity. At 0, it bent as it crossed. It has odd multiplicity. It worked 3 times. What's 3 plus 2? 5. How many zeros were you expecting? 5, right? Whatever that first one is, right? Okay? So when you see some bending and bouncing, that's telling you there's multiplicity involved with that 0, with that root. Okay? All right, here's another one. Just watch. What's happening here?
It's bending.
It's bending. So how many times at least does -2 work? 3. 3. 3. Right? Because it bent. Now, how can you check to make sure you're right?
Plug it in. Synthetic division.
Synthetic division, yes. You check the table to make sure it's at -2, right? Okay? So, this is the problem. 1, 6, 12, 8, 1, 6, 12, 8. -2 was the 0. So when I went -2 times 1, I got that -2. When I added, I got 4. -2 times 4, -8. When I added, I got 4. -2 times 4, -8. When I added, I got 0. When you get a 0 there, that tells you that it's a factor, right? It works. It's a 0. We've talked about that already, right? Do it again. So I just draw a line to the 4 now, because the 0 worked. Drop the 1 again. -2 times 1, -2. Add those, I get 2. -2 times 2 is -4. Add those, I got a 0. Supposed to work another time, so I try it again. I'm going to go to the 1 and 2. Drop the 1 again. -2 times 1 is -2. 2 plus a -2, 0. So I just proved that -2 worked 3 times. Okay? So synthetic division helps you if you're thinking it works more than once. Okay?
I love it.
Questions on that? You guys already know how to do synthetic division, right? Okay, so, it says identify the roots, shapes of multiplicity. So, just put it in your calculator. All right, I got the x to the fourth. It's plus 8x cubed plus 8 cubed plus 18x squared minus 27. How many? Oops, that doesn't look right. I put 86. How'd that happen?
That's good enough.
Right, so x to the fourth, 8x cubed plus 18x squared minus 20. I got it right now. All right, so how many zeros should I? 4. Yeah, 4. Should I see? Sometimes I don't see them all. That's okay. No bend. Well, what's bending, tell me? 3, and then it went through another spot, so there's the fourth one, right? It went one more. Okay? So, that's what it looked like.
How do you zoom out? Zoom in and out.
Hit zoom 6.
I appreciate it.
You're welcome. Go to your table, just to make sure. That looks to me like a -3. There's the 1. Go up to -3 and check. Okay, so it's -3 and 1. Okay? So our answer here would be three plus 1 gives me my 4 zeros. You with me? Okay. If I tried to factor this, like by grouping, it wouldn't work out. If I try to change the order and maybe group it that way, it gets kind of difficult to factor that. So we're just going to use our calculator to help. Okay? Actually, I could factor it now. If 1 is a 0, what's the factor? We've done this before. If 1 is a 0 or root, what's the factor? X minus 1, right? We always start x minus on these, remember? What's this factor? X minus -3, which I hear you guys saying plus 3. But what else do I put since it's a multiple of 3?
Square root of 3.
Third power, yeah. That's what you meant, right?
Cube.
So if I were to do this problem, figure this answer and, boil it all out, multiply it all out, that's what I would get. Okay? There's a big long one. Do you want to try to factor that big huge thing?
Yeah.
No, you want to put it in your calculator, right?
Yeah.
Okay? So, got the x to the fourth. It's minus 8x cubed plus 24x squared minus 32x plus 16. Okay, so again, how many am I expecting to see? 4, right? Let's see what happens. Down, up. Oh, maybe it's just bouncing off there. If it's bouncing off there, what am I expecting? At least 2, right? But it could be 4 because it's even, right? When it bounces. Now I'm going to zoom in on that to make sure it's bouncing off at the 2. All right, so I'm going to hit zoom, and I like to hit zoom box to put a box right around there. So I'm going to hit enter, and it's hard for you guys where you're at to see this, but it's blinking, my cursor's blinking right at 0, 0. So I'm gonna go up a little bit, and to the right a little bit, and start my box. And I'm just gonna, that's the top edge of my box. Then I'm gonna go down and that'll make my box. All right, so now it's just gonna, when I hit enter, it's just gonna zoom into that area. It's still kind of flat, isn't it?
Yeah.
So if I do that again, I could hit enter and then draw another box just at 2 there. And maybe I'll be able to tell for sure. I mean, that's the 2 right there. I believe it's 2. Can't see it. All right. So I'm thinking it's 2. So let's do this. How can I check? Synthetic, right? 1, -8, 24. Is anything missing? No. What if something was missing? Put the 0. We still do that, right? Worked that time, right? We're thinking it works at least twice, right? Let's see if it works a 3rd time. Oh, it does. Is it gonna work a 4th time? All my beautiful writing. 2 times 1. It does work 4 times, doesn't it?
Wow.
Okay? So our answer would be 2 with a multiplicity of 4. And I thought there was even multiplicity. Why? What did I see when I looked at it? What did it? Bounced off, right? What do I see if I think it works at least 3 times? It's bending as it crosses. Okay? Hey, you guys did a good job today.
How's the angle?
There's your assignment. Good start to the 2nd semester.
Where are you going?
Did you not have a note?
Oh, wow. To blame him.
We do already.
I totally will. Mr. Gardner,
Yes.
here's your calculator back. Thank you for
How much
letting
would
me
you
see
buy?
them.
You're welcome.
I can't find the charger for my